All right, we're back for the second half of section 5 in chapter 1, and all we're going to cover here is the order of operations. So first we need to remember that in math, the order definitely matters. If you'll look here in this example, just to prove it to you, 2 plus 5 is 7, 7 times 3 is 21. But if I follow the order of operations, which says multiplication comes first, 5 times 3 is 15, and if I add 2 plus 15, I get 17. Those two answers are not equal. So, in order, you know, I have told you I love math because we all get the same answer. But in order to all get the same answer, we all have to follow the same set of rules. So the order of operations, you may know them as Pemdas. You may know them as please excuse my dear Aunt Sally. Either of those are a good mnemonic device, a good way to remember the order of operations. You need to know a few details about those order of operations. So let's make sure with parentheses is our P and that's first. But remember, make sure in parentheses you've got to work from the inside out. So write yourself some notes from the inside out. And we'll do some examples so that you know what I mean by there. After everything from the inside out is worked, and then inside those parentheses, you also have to use the order of operations within those parentheses and work your way outward. Exponents are next. After you've worked out what's inside the parentheses, you work out what's in the exponents. The next thing you've got to be careful of, because Pemdas makes it look like, oh, I do all the multiplication and then I do all the division. That's not the case. So when you're memorizing your mnemonic device, make sure you're using it correctly and remembering what it means, because the M and the D have to go together. The multiplication and division, you do multiplication and division together from left to right. So you can't just willy-nilly go, oh, I'm multiplying and dividing and just pick and choose, oh, this multiplies, or this divides easier, let's do it first. You've got to start at the left and do whatever comes from left to right within either multiplication or division. Then your last step is you're going to add and subtract together, and you've got to do that also left to right. All right, and within that, if you're clear on your if you put your negatives on your subtraction instead of having it adding and subtracting, if you change it all to adding with adding the negatives, then remember it's all commutative and associative. So as long as you keep those negatives with their numbers, you can do that in any order that you wish. I will show you what I mean here. All we're going to do the rest of the time is just lots and lots of examples so that you can see exactly what we're talking about with each step. So first, we're looking at this one, and parentheses first. There's actually not any parentheses because these parentheses just hold that negative to that 3. So no parentheses here, no exponents. So now we're going to do multiplication and division left to right. So I'm coming along. There's a negative number. There's addition. Here's division. So I have to do this step first. So 12 divided by negative 3. 12 divided by 3 is 4. And it's a positive and a negative. The signs are different. So my answer is negative. So then go ahead and put everything that you've got left in your problem just like it was. Don't lose anything. All right, make sure that you bring everything down in this step. So then we go back to the beginning and say, okay, any other multiplication and division? And we say, oh yes, here's multiplication right here. So 4 times 5 is 20, and 5 was positive, but the 4 is negative. So my answer is still negative 20. Don't lose my negative 34 here. Negative 34 and a negative 20, you can in your brain say, oh, this is actually adding a negative. So two negatives together we add because the signs are the same. So we add them, 54, and because it was negative, my answer is negative because we're adding and keeping the sign. So the answer here is negative 54. All right, let's just keep doing some more examples. If you need to look at that again, back the video up and look at it again. If not, then let's just keep going. Something that you need to keep track of also is absolute values. Absolute values can work kind of like parentheses. So you've got to work what's in them first before you can combine them with the rest of the problem. So in this case, we're looking for parentheses, and there's no parentheses, but there is an absolute value. So work out what's in that absolute value. 18 minus 24. you've got different signs. 18 is positive, 24 is negative, so you're going to subtract because the signs are different. So 24 minus 18 is 6, and the 24 is bigger, so it is negative, but it's an absolute value. So negative, don't lose anything, bring everything down. The absolute value of negative 6 is positive 6. So now we've got 4. If it's right next to it, it means multiply. So now the positive 6 comes out of the absolute values. So now we have negative 2 to the 4th plus 4 times 6. So next step is exponents. So we're going to do negative 2 to the 4th. Now remember, this negative 2, remember from last lesson, because the 4 is on the 2 but not on the negative, we're going to keep the negative and we're going to take 2 to the 4th power. So 2 times 2 is 4, times 2 is 8, times another 2 is 16, plus 4 times 6. So now we go through and do any multiplying and dividing. And we have multiplication here, so negative 16 plus, because they're both positive, 4 times 6 is 24. And 16, 17, 4 is 8. So negative 16 and positive 24, because the signs are different, we're going to subtract. And so the answer is 8. And because the 24 is bigger, it is a positive 8. All right? So more examples. So if that didn't make sense to you, if any of those steps weren't clear, back the video up and look and see where did I get it. Send me a comment or a text and say, why did you get that? Where did it come from? All right, another example. Negative 5 squared, quantity squared, minus 8 times the quantity 4 minus the quantity of 6 plus 3. Now we're getting into some parentheses. All right, so now you're going to go parentheses from inside to outside. So we see lots of parentheses. We've got brackets and we've got parentheses inside those. So do what's inside here first. The 6 plus 3 is 9. So now we have 4 minus 9 inside these brackets. Don't lose any other part of it. Lots of steps on these. But it's going to be really easy just to drop off little things and lose them. Don't do that. Keep track of everything. Still more parentheses. So now inside these parentheses, 4 minus 9, we've got a positive and a negative. So you're going to subtract. 5 is the difference. 9 is bigger, so it's negative. So you've got negative 5 squared minus 8 minus square root of 36. All right. So then we've done all the parentheses because these parentheses are just around integers to keep our negatives next to our our numbers. So the next thing is exponents. And exponents and square roots kind of go together because they're opposites of each other. So you can do the square root in the same step also. So negative 5 squared is a negative 5 times a negative 5 is 25. Minus 8 times a negative 5. Minus the square root of 36 is 6. Alrighty. So now we don't have any parentheses. We don't have any exponents. Now we're going to do multiplying and dividing left to right. So starting on the left, 25 minus something. Ooh, this is multiplication. 8 times 5 is 40. Now be careful because the 5 is negative. The 8, this is going to be tricky. And halfway through the year, you'll figure out, oh, I get it. This can either be subtraction or a negative, and it's okay, whichever way it makes sense in your brain to call it that. What I like to do is, if there's a negative sign there, I call this a negative 8. And in my brain, I just always add a negative 8. So if there's a negative in front of it, I call it a negative 8. All right? So negative 8 times a negative 5 is positive 40. Two negatives make this positive. All right, and now is when we add and subtract, because that's all that's left from left to right. And this is where you simply make sure you're starting from the left and going to the right. Keep your positives here together. 25 and 40 is 65, and they're both positive, so your answer is positive. minus 6 is 59. All right, so start at the beginning. Make sure you understand each step. There we go. The next thing I want to put in here is making sure that you know within radicals, I never know whether you erase right away. I guess you can always just go back and get it. If you didn't get all the steps, you can pause somewhere in there. All right. Within radicals, okay, inside those radicals, if you have 36 times 4, you can either multiply that first and get 36 times 4 is 144, and the square root of 144 is just 12. Or you can divvy that up, kind of like what we did with the division problems. If you have a square root of a fraction, you can divide it up into a square root divided by a square root. You can also take this, the square root of 36 times the square root of 4, and do those separately. You can either multiply them first and then take the square root, or you can divide them up and take the square root first and then multiply, whichever is easier in your problem. So it's just a good trick to know whichever way is easier at the time. So the square root of 36 is 6. The square root of 4 is 2. And when we multiply those two together, we get a 12, which is the same as what we got up here. So that's our proof that, oh yeah, this works. Now look to see, does that work if you're adding underneath the radical? So if we have 9 plus 16, 9 plus 16 is 25. The square root of 25 is just 5. So let's see if it works the other way, because we have a perfect square and a perfect square. So the square root of 9 is 3. The square root of 16 is 4. 3 plus 4, is 7. Not equal. So this will not work. Make sure that if you're adding under a radical, you have to add it first. You can't take your square root first and then add your square roots. So if you've got an addition problem or a subtraction problem under your radical, make sure that you do that. Make sure you do that addition or subtraction first. All right. I've got 2 more examples, and they're big doozies. So let's see if we can do. I'll write it down and go ahead and pause just long enough to let me get ahead of me, and then see if you can get the same answer as I get. So we've got 12.4 divided by 5 times this quantity -3 squared plus 4 times the square root of 169 minus 25. All right. So the first thing, see if you can do it on your own and then come back. All right. Here we go. The first thing I'm going to do is look for any parentheses. And because this is a quantity, it works like a parenthesis. And so we're going to work what's under this square root first. So 169 minus 25 is 144. Keep everything. All right. Whew. Okay. So then we don't have any more parentheses, so we go to exponents. So this exponent is -3 squared. -3 times -3 is a positive 9. So keep this. Plus 4. And this is the opposite of an exponent, so we can do this at the same time as exponents. Square roots and exponents are in the same step. You might want to add that to your notes where it says exponents. You can put n square roots also. Put that in your notes. Square root of 144 is 12. Now we are finished with everything down. We've got parentheses. We did exponents. We did exponents. Now we're on multiplying and dividing. So we come along left to right. 12.4 divided by 5. I happened to have done that ahead of time. You can stick it into your handy dandy calculator if you want, or stick it over to the side. 2.48 times 9 plus 4 times 12. All right. So 2.48 times 9 is 22.32 plus, and here you can do this multiplication also because it's separated by that addition. So you can do this 4 times 12 in the same step. 4 times 12 is 48. And now we can simply add that together and we get 40, 50, 60, 70.32. I hope that's what you got. Let's do one more. Let's do one with fractions, because I know you love fractions, right? Yes, we do. All right, here we go. We're going to do negative 1/4 cubed minus 1/2 plus 3/8 divided by the square root of 48 thirds. All right, and don't scream and run away. This isn't hard. This is one step at a time. So, parentheses. Okay, parentheses. 1/2 plus 3/8. Now we have to remember we got to have like denominators. But if you look, 2 will go evenly into 8. So we can quickly and easily change this into eighths. 2 times 4 is 8. So 1 times 4 is 4/8. And so now we just take the 4/8 plus the 3/8 because our denominators are alike now. So that would be 7/8. So we're going to subtract 7/8. Keep all this part here. Okay, no more parentheses. We're done with parentheses. Woohoo! All right, now the exponents and square roots. So negative 1/4 cubed, remember, is negative 1/4 times negative 1/4 times negative 1/4. So on your numerator, you just have a 1. Your denominator is 4 times 4 is 16 times another 4 is 64. Yes, woohoo. And because there is an odd number of negatives, an odd number an odd numbered exponent on a negative base, my answer is negative. Negative 1/64 minus 7/8 divided by, and because we were doing exponents, we can also do square root at the same time. And in this case, I don't know what the square root of 3 is, and I don't know what the square root of 48 is. So this time it's going to be better to do the division first inside there, because 48 divided by 3 is 16. And I happen to know, and so then it's almost like this was treated as a parenthesis. Okay, so we can either do the division first and then the square roots. Remember that? We said that. So now the square root of 16, I can just say, well, the square root of 16 is 4. So it's kind of a little half step in there. I'm also running out of space, so I'm trying to do it all in one. Okay, so negative 1/64 minus 7/8. Oh, there's a multiplication or division. So when we divide by 4, remember we're going to multiply by the reciprocal. So I'm dividing by 4, so I can multiply by 1/4. All right, so when I multiply by 1/4, 7 times 1 is 7, 8 times 4 is 32. So now I just have negative 1/64 minus 7/32, and I can quickly see, ooh, 32 times 2 is 64. So 7 times 2 is 14. So now I just have 1/64, negative 1/64 minus 14/64. Because they're both negative, I add them. So 14 plus 1 is 15, and my denominator stays 64. All right. I won't do one with all of those fractions on the test, but I want you to be able to do them, so there will be 1 or 2 in the assignments. All right. Order of operations, Pemdas. Please excuse my dear Aunt Sally. Make sure you follow the rules and we'll all get the same answer. See you next time.